Okay, so we're going to do day 8 notes. It's about log and exponential inequalities today. So it's an extension of what we did yesterday with equations, but now obviously we have inequality symbols in our original problems. So I'm going to have you pause the video and write down the general steps, and then just go ahead and unpause when you're ready to start problem number 1. The first problem is an exponential equation, and we know that it's an exponential equation because it has this 6 to the x power. So since it has this, we know it's in exponential form. And so we're going to follow these steps that are over here. So the first thing we're going to do is isolate the base raised to whatever the exponent is. And that means we need to get rid of the 3. So the very first step is I'm going to divide both sides by 3. And I get 2 minus 6 to the x is less than or equal to 1/3. Then I'm going to undo the 2. So I'm going to minus 2 from both sides. And that gives me negative 6 to the x is less than or equal to 1/3 minus 2 is 1/3 minus 6/3. So negative 5/3. And then I'm going to divide both sides by a -1. And that's going to give me 6 to the x is greater than or equal to 5/3. So don't forget, when you multiply or divide by a negative number, that you will end up flipping your inequality symbol. So that's why it becomes greater than or equal to. All right, now at this point, I have isolated my base raised to the exponent, so 6 to the x power, and then there's just one number on the other side. And so I'm going to take the log of both sides. So this is really like the most important step. So I'm not going to convert to log form, but I'm literally going to write log of something on both sides. I'm going to do this over here just so that I can rewrite it and have more space. So I'm going to do log of 6 to the x is greater than or equal to log of 5/3. All right, now I can do log of any base that I want, but what would be the most beneficial base is whatever is going to match this 6. So since it has to match the 6, I need to put log base 6 of both sides. And the reason why that's going to be helpful is now I can use my exponent rules or my logarithm rules. And if I see an exponent, I can move that out to the front. And I've got log base 6 of 6 is greater than or equal to log base 6 of 5/3. And then now log base 6 of 6 cancels out because that's equal to 1. 6 to what power gives me 6? That's 1. All right, so now I just have x is greater than or equal to log base 6 of 5/3. And if you want to get a decimal approximation, you can have 0.285. You could do that on your calculator. So I would say as an exact answer, it would be anything greater than log base 6 of 5/3 to infinity, greater than or equal to, right? As an approximate answer, I would say that it could be 0.285 to infinity. And then notice I have a bracket for the left side, but I have parentheses for the right side. All right, moving on to problem number 2. Again, if you want to pause the video, write down all the steps, and then unpause when you're ready to start problem number 2. All right, so this is going to be a logarithmic equation to begin with, since it has natural log, right? This is in log form. And we should remember that in log form, we can only take the log of something that is positive. So we're going to find the domain first. And we know that 2 minus 5x has to be at least, well, it can't even be 0. It has to be greater than 0, right? So now I'm just going to solve that. So you can't take log of a negative number. You can't take log of 0. But I'm just going to solve this inequality. So negative 5x is greater than negative 2. And then I'm going to divide by a negative 5. So that means I'm going to flip my inequality symbol. So that becomes x is less than 2/5. So my domain is anything from negative infinity to 2/5, but not including 2/5. All right, so I'm going to keep that off to the side. I'm going to solve my equation, and eventually I'm going to go back and refer back to my domain and make sure everything matches up. So because it's in log form, I need to change to exponential form. And maybe as a little reminder, when you see natural log, that's really a base e. So I'm looking at what is my base, what is my exponent, and then that's going to be equal to 2 minus 5x, right? However, it's not an equal sign, it's an inequality sign. So there's the next step we got to be a little bit careful of. So you even put a little asterisk over here, keep the parentheses on the same side as the original. So I know it's going to be e raised to the second power, and that should be equivalent to 2 minus 5x, but I'm going to keep the 2 minus 5x on the left side. And I'm going to keep my inequality symbol as greater than, but I'm going to put my e squared over here. And the reason why we do that is because otherwise, if we do e squared and then put the 2 minus 5x on the other side, I'd have to switch my inequality sign, and people will forget to do that. So we're just going to say as a general rule, keep the parentheses on the same side as the original problem. Okay, so now I just have to solve for x. How do I get x by itself? I'm going to subtract 2. So I have negative 5x is greater than e squared minus 2. And then I'm going to divide by a negative 5. And we know that when we divide by a negative, we have to flip our sign. So it's going to be x is less than e squared minus 2 over negative 5. So that's an exact answer. As an approximate solution, I've got negative 1.078. So my answer is going to be anything less than that. So as an exact answer, I'm going to say that it can be anything from negative infinity to e squared minus 2 over 5. And as an approximate answer, we're going to have negative infinity to negative 1.078. And it's just less than, so I'm not going to include the bracket on the right side, just parentheses. All right, but now let's go back. We don't have to necessarily test points. That's going to be something like when we do problem 3 with like a rational equation or inequality. But we do have to do step 4, which is check against the domain. So in my original domain, I said that I could have any value as long as that value is between negative infinity and 0.4. And everything within my solution set is actually okay because everything's less than 0.4. We don't even get to the positives. We get to negative 1.078. So we're good there. We don't have to adjust our answer. All right, moving on to problem number 3. So is this a log or an exponent form? This has the word log in it, so this must be log form. Okay, so it's going to be similar to problem number 2. So we're going to follow these steps. All right, but we are going to have to test points on this one because we do have a fraction with variables in the numerator and denominator. All right, so anytime we have a log equation or inequality, we're going to check our domain first. So whatever's in the parentheses, 2x minus 1 over x minus 2, can't be negative and it can't be 0, so it has to be greater than 0. But now we have to remember how to solve inequalities like this. So we did this back in chapter 2, so at the very beginning of the school year. We had to find key points. And the way that you find your key points is you look at what makes the numerator 0 and what makes the denominator 0. We're going to solve those little equations. So we get x equals 1/2 and x equals 2. And we're going to make a number line. And we're going to plug in values within those 3 zones. So I've got 1/2 and 2 labeled on my number line. I need to pick one point in each of those 3 areas, and we're just going to test them. Okay, so let's pick a number that's less than 1/2. I think 0 is always a really nice number to select. So we've got 2 times 0 minus 1 over 0 minus 2. So that gives me negative 1 over negative 2, which is actually a positive. Okay, so I'm going to label that zone as positive. All right, and then a number between 1/2 and 2. That's 1. So 2 times 1 minus 1 over 1 minus 2. That gives me 2 minus 1, which is 1. 1 minus 2 is negative 1. So that gives me a negative value. I'm guessing the last region is going to be positive, but we have to check anyway. So I'm going to plug in the number 3. So 2 times 3 is 6, minus 1 is 5, and 3 minus 2 is 1. So that is a positive. All right, what are we looking for? We're looking for greater than 0. So we want anything here and anything here. So this was not solving my equation. This was just identifying the domain. So that is anything from negative infinity to 1/2, not including my numbers because it can only be greater than 0. It's not equal to 0. And then we're going to do a union symbol, 2 to infinity. All right, so now we're going to actually solve our problem, going back to the original inequality, and we're going to check our answer eventually against that domain. Okay, so it's a log form equation or inequality, and we need to convert it to be exponential form. But remember, when we convert to exponential form, we're going to put the 2 to the 0 on this side, on the right side, and we're going to keep this part in parentheses on the same side of the inequality. That way we keep our inequality symbol as less than. All right, now we get it to simplify. We should know that 2 to the 0 is equal to 1. All right, but now how do we solve something like this? Similar to how we found the domain, but we have to have it all less than 0. So the right side needs to be 0. So I'm going to do 2x minus 1 over x minus 2. And I'm going to subtract 1. And I'm going to leave a space over here because we're going to actually have to do a little bit more work. Because I need to combine this into a singular fraction, I need to get common denominators. So best common denominator would be to pick x minus 2. And so I'm going to distribute a negative 1. You only distribute it on the top because it's negative 1 over 1. You need to write that there to help you. Go ahead and do that. So I haven't changed anything on the left fraction. That's still 2x minus 1 over x minus 2. I'm going to change this to a plus sign. And negative 1 times x is negative 1x. Negative 1 times negative 2 is positive 2. And on the denominator, I have x minus 2. So I do have common denominators. I'm going to combine that into one singular fraction. So 2x minus 1x is just x. And negative 1 plus 2 is 1. So I have x plus 1 over x minus 2 is less than 0. So finally, I have a singular fraction. I can check out my key points. You should be able to do that in your head. But x plus 1 has to equal 0, and x minus 2 has to equal 0. So my key points are at negative 1 and positive 2. All right, so now I'm going to make a number line for the actual problem and test numbers within those 3 zones. So I've got anything less than negative 1. I'm going to test out maybe negative 2. I wouldn't go too far below negative 1, but negative 2 plus 1 and negative 2 minus 2. That gives me negative 1 over negative 4, which is positive. All right, then I'm going to do 0 will work between negative 1 and 2. So I'm going to do 0 plus 1 over 0 minus 2. That gives me 1 over negative 2. That's negative. And then I'm guessing it's going to be positive, but let's just verify that. So I'll substitute in 3. So 3 plus 1 over 3 minus 2. That is 4 over 1. And that's positive. All right, what are we looking for? We're looking for less than 0. So I want any number that's in the negative zone. And it can't be equal to 0, so I'm not going to include negative 1 or 2. So I think my interval is between negative 1 and 2. So now we have to go back and verify that the numbers within my domain agree with the answer that I have. So negative 1 to 2 is what I think my answer is, but my domain says I can only pick numbers between negative infinity and 1/2, and then also any numbers from 2 to infinity. Okay, so we don't have any values between 2 and infinity in my, what I think is my answer. But I do have numbers from negative infinity to 1/2, but 1/2 is going to be the largest I could possibly pick. So since it has to satisfy this and this at the same time, I can only pick numbers between negative 1 and 1/2. I can't go all the way up to 2, because remember, anything between 1/2 and 2 was in my not allowed zone. So my final answer should be between negative 1 and 1/2. We'll label this as our final answer. This is what I originally thought my answer was, but since it didn't agree exactly with my domain, I had to adjust that. All right, so this is probably going to be the hardest type of problem that you'll encounter, especially with the solving and making sure you remember to check for key points, but always verify against the domain when you start with a log problem. All right, so for problem number 4, we're going to follow the general steps that we have up here for exponential equations. So we're going to isolate the base and the exponent, and then we're going to take the log of both sides. So I know this is exponential form to begin with, because this has a base of e. I have an exponent that says 1 over x minus 1, and then my number 1 is just the number. So I need to take the log of both sides. So I'm going to write log and log. I'm going to do log of e to the 1 over x minus 1. I'm going to keep my inequality symbol as greater than, and I'm going to do log of 1. But remember, I can do any base that I want to, but the best base is going to be the one that matches the base from the original exponential form of the inequality. So I'm going to do log base e and log base e, which we should know that log base e is natural log. So I'm going to rewrite this. Natural log, I'll even put in the base e here, of e to the 1 over x minus 1 is greater than natural log of 1. All right, so now I'm going to use my exponent rules. When I have logs with an exponent, I know I can bring this out to the front. So 1 over x minus 1 times natural log of e. So e to what power gives me e? That's going to be 1. So I know that's going to cancel out. That's why we want to use the same base, because I want to get something to cancel. And then this is going to stay as natural log of 1. All right, so what is natural log of 1? Right? This is base e. E to what power equals 1? E to the 0 power equals 1, right? So this is 0. I'm just going to replace that. And the only thing I have on my left side is 1 over x minus 1. I'm going to need to get common denominators so I can get a singular fraction. So I'm just going to multiply the 1 by x over x. So that gives me 1 over x minus x over x is greater than 0. So when I combine that into a singular fraction, I have 1 over x. No, 1 minus x over x is greater than 0. All right, so let's look for our key points. What makes my numerator equal to 0? What makes my denominator equal to 0? We've got negative x equals negative 1, so x equals 1, and x equals 0. I'm going to look at my number line, and I'm going to put in 0 and 1. All right, so I'm going to substitute in some values to test some points. So a number that's less than 0 is negative 1. So 1 minus negative 1 over negative 1, that gives me 2 over negative 1, that's a negative 2. So that's negative. A number between 0 and 1, I'll go with 1/2. So I get 1/2 over 1/2, which is 1. That's positive. And then a number bigger than 1 would be 2. So I'm going to do 1 minus 2 over 2. That is equal to negative 1 over 2. That's a negative value. So what do I want? I want values that are greater than 0. So I think my answer is between 0 and 1. And because the original problem started with an exponential form, then I know that it has infinite domain. So anything would be allowed, anything from negative infinity to positive infinity. So the answers that I got were 0 to 1, not including the endpoints. So we're going to keep that as our final answer. All right, the last two problems are a little different. It just says solve the following equations for x in terms of the other variables. So where is x in our problem? There's a whole bunch of other variables. So we just need to isolate x, which might mean that you need to change it from log to exponent form or exponent to log form. And these are equations. They're not inequalities, so we don't do anything like problems 1 through 4. So it's more like yesterday's. Okay, so if we divide both sides by a, we can try to isolate my base and exponent. So I have y over a is equal to e to the kx. And then this is exponential form. And if we could just convert it to log form, that would be the easiest thing to do. And it's an equation, so it doesn't matter what side you put things on. But we're going to do log base, whatever my base was, which happens to be e. So log base e equals, I'm going to put my exponent on the other side of the equation, and I'm going to put y over a in the parentheses. All right, and a better way to say log base e would be natural log of y over a is equal to k times x. And then I just need to solve for x. So we just need to divide both sides by k. And then I should get my final answer. So natural log of y over a all over k is equal to x. And then I should be done. It just says solve for x. So we're finished. All right, in problem number 6, this one is log form, right? I see natural log and natural log. But it would be nice to condense. So if we could condense using some of our log rules, I see a coefficient, so that can become an exponent. So I could have natural log of x to the alpha. So alpha is like a Greek letter there. And I've got plus natural log of beta. We've got another Greek letter. It equals 0. And then if I see addition, I know that that can be condensed using the log property with multiplication. So I'm going to keep it as natural log, but then I get to multiply x to the alpha times beta. And that equals 0. All right, so since I've got log form, I would probably like to convert this to exponential form in order to solve. And so I need to know what is my base. My base is actually e. So I need e to the 0 power is equal to x to the alpha times b. Okay, how much is e to the 0? E to the 0 is equal to 1. We've got x to the alpha times b, or beta, sorry. And we're still trying to solve for x, so I'm going to divide both sides by beta. I have 1 over beta is equal to x raised to the alpha power. I'm going to now look at how do I undo the alpha power. And if it was a squared, I would undo it by taking the square root. So I can still do the same concept here. I could take the alpha root of both sides. And if I take the alpha root of both sides, that cancels out my alpha. So I just am left with x. And this is the alpha root of 1 over beta. All right, and then we're all done with these notes. So if you have any questions, make sure that you ask your teacher in class. Have a nice day.